Hello everyone, welcome back. This is the lecture 5 of CSES Dynamic Programming Series, and today we are diving into another interesting problem, and the problem name is grid paths. Okay, so grab your notebook, stay focused, and let's get started. Let me read the problem statement first. Consider an n cross n grid whose square may have a traps. Okay, it is not allowed to move to a square with a trap. Okay. Your task is to calculate the number of paths from the upper left square to the lower right square. You can only move right and down. Okay. So we are given an input size n. Okay. So we have to print the number of paths and take the modulo, and constraint is up till 1000. So yes. Now let me just copy this. Yes, this example and pasted it here. Yes, okay. So our goal is to find the number of ways to uh, to start with this index and reach with lower left corner. Start with upper left corner and reach lower right corner, and we have to find the number of ways. Uh, where star represents the trap at the ith and jth column, ith row and jth column, where dot represents no traps. Okay, so I hope the problem statement is clear to everyone. Now let's move to our solution. Okay, in order to solve the problem, first we have to define the states of dp. Okay, dp of I comma j represents the number of ways uh, to reach ith row and jth column. Okay, so let me just again copy this. Yes, okay, yes. So dp of ij represents number of ways to reach ith row and jth column. I think this much is clear to everyone. Okay, now first we will go through the recursive solution and then we will move to tabulation because it will be much easier for us. Okay, so if I'm standing on this index, like I usually do recursively from backwards to front. Okay, some people prefer to go from 0 to n, but I prefer recursively go from n to 0, and for the tabulation I prefer go from 0 to n. Okay, so I will move forward with n to 0. Okay, so yeah, so if I'm standing on this index, the I have two options, right? Either I can move right, okay, either I can move down. Okay, so if I'm standing on this index, okay, so we have two options. Either I can go right or either I can go down. Okay, we will convert this into basically outwards. Okay, this is right or this is the left. Okay, this is upwards. Okay, so my recursive states would be look like this: f comma I comma j n comma m n comma grid. Okay, grid and dp. Okay, yes, if I'm standing on this index, okay, either I can go upwards or either I can go downwards. If I'm going if I basically reach this index, okay, without any disturbance, if I reach this index, then my answer will be incremented by 1. Right or wrong? Yes, because I have to go from top left to bottom right. Okay, if I make this path, if I make this path, okay, then my answer will be incremented to 1. Okay, yeah. So, but remember that I have to avoid these traps. Okay, I have to avoid these traps. So I will, if if I accidentally if I accidentally reach this index, if I accidentally reach this index, next I will simply return 0 because I have nowhere to go, because it will give me a 0 answer. Okay, it will be much better if I will show you the direct code implementation. Okay, so this is our problem. Yeah, so yes, this is my recursive code. Okay, if I go out of the bound situation, then I will return 0. Yes, basically it means that uh, if I go if my row is less is my row is 4, if I go less than 4, then it will simply return 0. Or if my column is also 4 and it will go to the fifth column, and a fifth column doesn't exist, so it will become 0, return 0. Okay, if I reach the very top corner, then I will return 1. Yeah, okay, if I reach this, then I will return as 1. Okay, so if my v of ij comma is equals to star, then I will simply return 0 ways to go. Okay, then I will move towards, then I have two options. Either I can go up comma j grid dp, or either I can go down fi j minus 1 grid comma dp. So the total number of ways would be should be up plus down. Okay, so this is the total number of ways to get. Okay, yeah, I minus 1 j, or I j minus 1 dp of ij is equals to up plus down. Yes, so this is my recursive solution. Okay, so it gives me wrong answer because we have to do the tabulation part also. So let's move to the tabulation. We have already defined the states of dp, right? Dp of ij is already defined. Okay, so what is the transition now? Okay, what is my transition? So my transition is like that. If my dp, I have to add the number of ways from the top. Okay, uh, yeah, I have to copy this one, right? Yeah, just give me a minute. Yes, so if I'm standing on this index, I have to add the number of ways to reach this index. Okay, I can reach this index via this. Okay, I can reach this index via this. Yes, so there are two options to reach this index. Okay, so my transition is look like something look like this. I minus 1 j, I minus 1 means previous row jth column. Okay, and ith row j previous column, right? J minus 1. So in dp of ij, I will add these two, right? It will give me a number of ways to reach dp of ij. dp of ij is equals to dp of I minus 1 j plus dp of I j minus 1. Yes, then we can take modulo of that. Okay, so now states has been defined. This is my transition uh, states dp of icon j. Let me just quickly write this represents. Okay, now state is clear, transition is clear. So now my final answer is stored in dp of answer. Final answer is dp of n comma n, because we have to reach bottom right corner. So my final answer is dp of n comma n. Yes, this is my whole pseudo code basically. uh, so one thing is left is what is my base case. Yeah, this is very important actually. Yeah, one thing also left is, what if my v of I is star. Basically, if v of I j is equals to my star, then I can simply copy my previous states, nothing else. Okay, then I can simply copy my previous states. Okay, yeah. So this is my base case actually. For the row, this part is for the row, this is part for the column. Okay. If my zeroth row and my previous row is equals to star, it means I cannot move forward. Basically, what I mean to say is, if my base case is like this, zero star row है ना, yes, star star. If my first is this, okay, so I can move forward, I can move downward. Okay, so my dp of 0 comma 1 is 1. Okay, and if my second is also dot, then I can assign 1. But for this I cannot move forward, so I will assign 0. Okay, so for this I cannot assign 1, because my previous is also star. My previous is also blocked by my previous is also blocked, so I will assign this as 0. Yeah, so this is my base case actually. So it's same for column. Okay, so yeah, then if my v of I minus 1 j minus 1, basically this is one base indexing. You can write this as 0 base also. Then I will assign dp of I j is equals to 0. It means it is basically the previous states. Okay, so this is my transition dp of ij. uh, I will copy the previous. uh, yes, I declare it, huh? Yeah. Okay, so this is same as, okay, I will then as the final answer is stored in dp of n comma n. Yeah, that's it. Thank you very much, guys. Okay, so this is very easy problem, I guess everyone can solve it. Okay.